Hello and welcome to Foundations for Algebra, Unit 4A, Lesson 1. Today, scholars will simplify exponential expressions with positive exponents. So first we need to talk about what is an exponent. When we're looking at exponents, they have two parts. The base is this bottom number down here. And then this top number is called the exponent. This top little number is called the exponent. So what does 7 to the third power, that's how you say it, 7 raised to the third power mean? It means 7 times 7 times 7, or 7 times itself 3 times. The base tells us what we're multiplying. The exponent tells us how many times we're multiplying it. So just a quick list of our definitions. The base is the part of the exponent that shows what is being multiplied. It's the big number. The exponent is the part that shows how many times. It's the little number. Then we have what's called expanded form. So you've seen the exponent 7 to the third power. That is the exponential form. The expanded form is, writing it out, 7 times 7 times 7. It can be helpful when we're learning about different powers of exponents. Okay, so how could the expanded form help? Here I have 5 to the fourth times 5 to the third power. If I write each of those out in expanded form, so 5 to the fourth is 5 times 5 times 5 times 5. And I'm multiplying that times 5 to the third, which is 5 times 5 times 5. Well, when I look at that, I can count and say, okay, I have 1, 2, 3, 4, 5, 6, 7 5s now. So this just becomes 5 to the 7th power. And now let's try it with this second problem. Here I have x squared, which is x times x. And I'm multiplying that times x to the 6th, which is x times x, 3, 4, 5, 6. So now if I count my x's, I have 1, 2, 3, 4, 5, 6, 7, 8 x's. So this is just x to the 8th power. Not too hard, right? From that, with this. This is called the product of powers property. Our product just means multiplication. And you saw that's what we were doing. We were multiplying. So whenever we multiply two exponents with the same base, remember this is only works if they have that same base number, you just add the exponent. So I have a to the n. This is a symbolic way of representing times a to the m. So the same base, different exponents. I just add my exponents. You can see here I have 2 to the fourth times 2 squared becomes 2 to the 4 plus 2. 4 plus 2 is 6. So it just becomes 2 to the 6th power. Very simple and easy. Well, now let's look at this one. We are looking at how the expanded form can help here. So I have 2 to the third power squared. So that is 2 to the third power times 2 to the third power. Everything inside the parentheses acts like the base. Well, if I have 2 to the third power times 2 to the third power, I know that I'm just going to add those exponents, so that gives me 2 to the 6th power. Let's try it with the k. So here I have k to the 4th power raised to the 3rd power. So I have 3 k to the 4th powers. K to the 4th times k to the 4th. And I know I'm just going to add these. So 4 plus 4 plus 4 gives me k to the 12th power. Again, we could actually write these out even further and write 2 to the third as 3 2s, but you do it this way and use the other power. Okay, so that's not too hard, right? So this is where we get our power of powers property. So we have a power raised to a power. So when raising an exponent to a power, you multiply the exponent. So here I have a base to a power of m raised to the power of n. I simply multiply. So here we see it. We have 3 squared to the 4th power is 3 to the 2 times 4, which gives us 3 to the 8th power. So in this case, we're going to multiply our powers. And we've got one more different way of looking at these. Here I have exponents being divided. So 5 to the 7th power is 7 5. So I have 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6, one more 5. All over 5 squared, which is 5 times 5. Well, I know that 5 divided by 5 is going to be 1. So those are going to cancel. And those are going to cancel. I'm left with 1, 2, 3, 4, 5, 5. So this is now 5 to the 5th power. Here I have w to the 8th divided by w. Okay, so when we see a number that doesn't have an exponent, there's always an exponent of 1 that we don't write. So here I have w to the 8th, so I have 8 w's. 1, 2, 3, 4, 5, 6, 7, 8 w's divided by 1 w. Okay, once again, w divided by w just gives me 1 and it cancels. So I'm left with 1, 2, 3, 4, 5, 6, 7 w's. So I simply get w to the 7th power. And one more. Here I have 9 to the 4th power divided by 9 squared. So 9 times 9 times 9 times 9 divided by 9 times 9. Again, out of the ones that have 1 on top and 1 bottom, I cancel, leaves me with 9 squared. Very simple and easy. So, this is our quotient of powers property. If you'll notice on the last slide, when we had the same base raised to different power divided by base raised to a different power, we just subtract. So I'm just going to subtract my exponents. So if I have 3 to the 8th power divided by 3 to the 4th power, I do 8 divided by 4 because 4 of them would cancel out, which gives me simply 3 to the 4th power. Okay, so now you're going to use all of these on your practice. I will see you in class.